In this proof, I'm going to demonstrate the strategy of using a theorem to help you make progress in a proof. This is an advanced strategy. You're not going to need it for any proofs on the exams or quizzes. However, if you're looking to increase your arsenal, it actually can be a really useful technique. And in fact, there are some proofs that I've gotten on your graded practice where this technique could have shortened or even just made the proof a little bit more intuitive. The essence of the strategy is that theorems can be proven for free, or that is from zero premises. That means that when proving a theorem, we just start with nothing and help ourselves to an assumption either for CP or IP, and then prove the theorem. What happens is, in the context of an argument for any given argument, you can always just, if you will, insert the proof of a theorem and get that theorem almost like an additional premise. And you're getting it for free because theorems are derived for free. The biggest strategic question is actually when you will know whether or not a theorem is going to be useful to you. That is to say, when do we know that we want one? In this proof, for example, when we look at lines 1 and 2, we see that we almost have a CD pattern, provided that we had the sentence A or not A. So to translate to some of the language that we've been using before, if we were working backwards, right? If we were working backwards and we had a wish list, on that wish list would be A or not A, so that we could use CD with the conjunction of lines 2 and 1. The resulting sentence would be B or F or R. Why would we want this disjunction? On the one hand, it's just something else that we can get, and it's a little bit more progress in the proof. But it's also a clear path to our conclusion. After all, because this disjunction is two disjunctions, we can use association in order to derive B or, in parentheses, F or R, and then that pairs with line 3 and DS to derive our desired conclusion. And whether or not you're at a place where you can see that many lines ahead, you know, certainly that's a skill that you're going to develop as you do more and more proofs. But we don't even need to see the rest of this yet. What indicates that a theorem, because this is a theorem, might be useful, is actually just in the idea that CD might be useful here. Now, of course, we don't have the ingredients to derive A or not A using add, let's say, because we don't have A. But as a theorem, we know that we can derive it for free. And how? Well, the same way that we would be deriving this theorem if we were proving it as a theorem. In other words, we would start in a subproof with, in this case, an assumption for indirect proof, for the simple reason that we're not trying to derive a horseshoe. There's a way to prove this theorem using CP, which is very handy, but the way that we've seen the proof before was using an assumption for indirect proof. Then we De Morgan's line 4. I've made my line too long again. That's already our contradiction, and so then at line 6, we close our subproof, discharging our provisional assumption, citing lines 4 through 5 in direct proof, and double negate on line 6. And of course, I don't, those parentheses wouldn't be wrong, but I don't need them. And then, why did I want this disjunction? It was to use CD, which means that we have to derive the conjunction of lines 1 and 2, B or F, and not A, then R. This is going to be 1 and 2 conj. Now we have the pattern for CD. That gives us B or F or R, 7, 8 CD, and we roll, and then we continue with the proof as we hoped for. B or F or R using association, and then that allows us to derive B using DS on lines 3 and 10. The basics of this strategy are straightforward. You can get a theorem for free whenever you want, and that includes in the context of a proof that you're already in. The harder part is recognizing when a theorem might be useful, and that just takes a little bit of experience, really. And commonly, there's innumerable number of tautologies, in fact. But commonly, the most useful theorems are the so-called law of excluded middle, which we've seen many times before, and also the law of non-contradiction. And then there are others, but these are the two most common theorems that are useful to you in proofs. And the bottom line is that they can be derived for free. And so, of course, as I've written them, they're substitution instances of theorem forms. But if you're in the context of a proof and you're like, boy, gee, I wish I had A or not A, for example, to use CD, as in this proof, just remember that you can actually get it.